Okay. All right, single replacement is the next type of reactions. Very simple. Basically, you have one element that's by itself. It reacts with a compound, and it may or may not displace the element in the compound. Okay. The way that we know this is we're going to have something called the activity series, and it will let you know if something will replace something else. Metals will only replace other metals with the exception of hydrogen, and nonmetals will only replace other nonmetals. So this activity series is something that you have to use. All of these words that are here, just ignore them. We don't care about the words. Scribble them out if you want. Because it was one of the few activity series that had both the metals and the nonmetals together, so I used it. So the way the activity series works is the most reactive is at the top. So lithium up here is the most reactive. Lithium can replace anything on the list. So lithium's like top dog. It wins. It will replace everything. Down at the bottom, you see gold. Gold can replace nothing. Okay? Which, if you look like gold, silver, and platinum, what do we like to make out of that?
Money.
That's usually paper. Jewelry. Yeah, we like to make jewelry out of gold, silver, and platinum. The reason we choose those metals to make jewelry and stuff out of is because they're not very reactive. So they're not going to be replaced, or they're not going to like react with something and go away. Okay? So that's why they're at the bottom, because they're fairly unreactive. Sometimes they're called noble metals, which is a word you haven't heard before, because they don't react. They're not very reactive. Things like platinum, rhodium is one as well, palladium. So the way it works is if it comes below it, it can replace it. If it comes above it, it can't. So if I'm looking at, say, magnesium right here, can magnesium replace lead? Yes. So magnesium would be able to replace lead. But can lead replace magnesium? No. Okay. Same way for the nonmetals. Fluorine can replace everything. Iodine can replace nothing. So this one has just the halogens. Oxygen fits in here, and I have to always look this up. It's either oxygen either fits in between fluorine and chlorine, or chlorine and bromine, and I never remember, and I have to go look it up. I'm pretty sure it fits in here because it's got a higher electronegativity and more reactive, but I would tell you that. I would say, hey, it will do it because it's not on this list. You do get this list on a test. You do get the activity series. I don't even have the activity series memorized. I mean, generally I know where they are, but like in the middle part, I have to come look it up. I'm like, oh, will zinc replace aluminum? I can't remember, so I have to go look it up. Okay? I obviously know that lithium can replace everything, gold nothing, but in the middle part, I have to look it up. So you do get the activity series on the test. Okay? All right. But you don't have to memorize that. Okay, so what does this look like? First of all, when we're looking at it, metals replace metals. Okay? And it does not matter which way I write this. I can write lithium plus KCl, or I could have written KCl plus lithium. It does not matter. Okay? So what I want to do, though, is I want to look at what's by itself, and I want to say, will it replace what's in the compound? So sometimes kids do that backwards, and they get confused. So you don't have to draw the arrows. I just choose to draw the arrows. Hold on. Okay. So you don't have to draw the little circles and arrows. I just do it to show you what we're going to do. So I say, will lithium replace potassium? Look at the list. The answer is yes. So now I'm going to write lithium chloride. So I would write lithium chloride plus potassium's been kicked out to the curb all by its little self, so it's going to be plus K. Then everything's 1 to 1. We do a little happy dance. That makes life easier, and we're done with that one. Okay? And then the next one is, will tin replace hydrogen? And I know that hydrogen's not a metal, but if you look at your activity series, it does show up in there. And the reason it shows up in there is because metals can be very reactive, especially with acids. And some can be reactive with water. For instance, the alkali metals are highly reactive with water, and it kicks out the hydrogen. Okay? So according to this list, will tin replace hydrogen? Yes, it will. Okay? And so it's going to kick hydrogen out. And so we're going to make tin chloride. How do I know which tin? Pick one, but generally the lower charge is the more common one. So tin can be a +2 or a +4. and generally 10-2 is more common. If you did it as 10-4, you would be perfectly fine, and I would count it correct because it would be correct unless it's specified. So I'm saying in this case, let's use 10-2 because it's more common. So how do I write 10-2 chloride? SnCl2, and then it kicked hydrogen out, so hydrogen's now all by itself. So how do I write hydrogen when it's all by itself? H2. So now I go back, I've written everything correctly, and now I balance. So how do I balance this? Put a 2 in front of the HCl, and now it's balanced. Okay? So now let's look at 10. Will 10 replace zinc? No, it will not. What do we do when it's a no, we're not? Well, this is what I do. I say NER, which really stands for no reaction, but it's more fun to say NER. Try it. NER. NER. Yes, play along at home. All right, so that would be a no reaction. You can write out no reaction if you want, or you can just say to yourself, NER. Not on a test, say it in your head. Don't say it out loud. Okay. All right. And then the next one is nickel plus HOH. What is HOH? It's water. It's water. But the reason I write, yeah, I'm not trying to do. Okay, it is water. I write it like this for a reason, because when something reacts with water and kicks out the hydrogen, and it's going to also be important when we get to double replacement, I'd write it so that you can see that this is how water will break up. Okay, so it's the same thing as H2O. I just write it like this to show you how is it going to break up. Okay, and so will nickel replace hydrogen? Yes, it will. So it's going to kick out the hydrogen, and it's going to make nickel hydroxide. It's going to make nickel 2 hydroxide to be specific. Okay, so how do I write nickel 2 hydroxide? NiOH parentheses 2 plus hydrogen. H2. So now I need to balance this. So what do? 2 water. Okay? You don't have to write water as HOH, but a lot of times if you write it as H2O, people don't realize how it goes together when it breaks apart. Okay, so that's why we write it that way. You don't have to. All right? So that's how we do the single replacement for metals. Okay, metals replace other metals or hydrogen. Okay, so now let's do some nonmetals. So for nonmetals, we're going to look at what's by itself and will it replace the nonmetal in the compound. So will chlorine replace bromine? Yes, it will. So I'm going to make NaCl. And when it kicks out bromine, what is it? How do we write that? Br2. Brinkle. It's the br in Brinkelhoff. Okay. So I need to balance this. So what do I do?
2 and
a 2 and a 2, right?
Yes.
Perfect. Okay. Now I look at the next one and I say, will fluorine replace bromine? Always. Fluorine's top dog. So I'm going to have magnesium fluoride, which I write MgF2 plus bromine by itself, Br2. Do I need to balance this? No. Happy dance. It's already balanced. Okay. Now how about the next one? Will iodine replace bromine?
No.
Thank you. No reaction. And then will bromine replace chlorine? No. See, it is fun to say, isn't it?
Yes.
I told you. Okay. So now let's do a couple more examples together, and then you can go on about your merry way and complete that page.
Why do you write it as F2 on the bottom one, but not Cl2 on the top one? Because,
Huh?
okay.
Oh, because of their charges. Magnesium's a +2, sodium's a +1. Yeah. I still have to write them correctly, right?
Well, is it only these 4 elements, well, these 5 elements that are involved with single replacement?
For the nonmetals?
Yeah.
Yeah, for pretty much. I mean, oxygen can be thrown in there sometimes, but pretty much. Most of the time when we're doing single replacement, we're doing with metals. Yeah. This is sometimes how single replacement reactions or how we can coat something. Like if I wanted to like coat zinc or something like that, or do it like that. Or if I want to purify an ore, I can do it by a single replacement reaction by having something replace what's in there and pull out like the silver and get that purified. So mostly we deal with metals, but I've never really done the single replacement with other nonmetals than what we have here. Okay, so let's do a couple of examples together. AgNO3. How do I write that? Oh!
Yeah, you're like, what?
I was like, why aren't y'all answering me? We write silver nitrate as AgNO3.
No way.
So see, that's how ingrained those things are into my head. I don't even read it as silver nitrate. I read it as AgNO3. Yeah.
Wow.
Nickel, Ni. Will nickel replace silver?
Yes.
Yes, it will. So we're going to write nickel, we're going to use nickel 2, so nickel 2 nitrate. So how do I write nickel 2 nitrate? Ni, NO3, 2 of them. And then silver all by its little self? Just Ag. So how do I balance this? Like so. Good job. Is that right?
And then 2 AG.
Yeah.
Shared did that.
Okay. So how about sodium bromide and iodine? Will iodine replace sodium bromide? Or will it replace the bromine? It will not. So I don't even have to bother writing all this stuff. I can just go, ner. Done. Okay. And then magnesium plus nitric acid. So Mg. How do I write nitric acid? HNO3. So will magnesium replace the hydrogen? Yes, it will. So how do I write magnesium nitrate now? NO3, 2. Plus, how does hydrogen go by itself? H2. So now I need to balance. So what do I need to do? Done. Not so bad. Especially when you know you get the activity series on the test. You get the list, yeah.
That's
You
the
get
one
the
of only
list.
lists you
Okay.
actually get.
Told y'all it was a short lesson. That was like only not even 13 minutes.